Welcome back everyone. In today's session we are going to see the introduction of a new chapter which will be revealed at the end of the chapter. The chapter name will be revealed at the end of the chapter. So to begin with, we will try to answer some questions like how many types of triangles do we have. So you have been learning about triangles from your lower classes about different types of triangles. Then we will also see how do we find area of triangle if base and height is given, which you have done in your previous classes. And the most important is we are going to see how do we find area of triangle if length of three sides is given. Okay, so let's begin. So you can see here there are different types of triangles based on sides. If all the three sides of a triangle are equal, then we call them as equilateral triangles. And if any two sides of a triangle are equal, you can see in this these two sides are equal, these two sides are equal in this type of triangles are called isosceles triangles. And if no sides are equal, if all sides are unequal, then we call them as scalene triangles. You have been learning this classification from 6th class. Okay, and you made many charts based on this concept. Then here there is another type of triangle, that is right angle triangle, you can see. And this is also one of the right angle triangle, you can see here. This is also a right angle triangle. This is called isosceles right angle triangle. Okay, and this is also right angle triangle but scalene right angle triangle. Okay, so now we will proceed to the areas. How do we find areas of these triangles? Okay, now to find the areas of these triangles, we generally used this formula, half into base into height. In 8th class you found areas of triangles by using the formula half into base into height. Okay, but is it the only formula to find area of triangle? Yes, let's check out. So if base and height is given, then we can use this formula. Okay, like for this triangle, if this base is given to you, this is the base, and if this is the height, okay, this is the height, then we can find area of this triangle. And for this triangle, if this is the base and this is the height, then I can find it area of this triangle. Okay, just imagine if height is not given, like imagine there is one complex or there is one park. You can look at this with a red color boundary, okay, in a locality. So there is a complex whose length of sides are given, very large complex, 6 kilometer, 5 kilometer and 4 kilometer. These are the three sides of the triangular complex. Here height is not given to us. Okay, height is missing. So my question is, can we use half into base into height here? No, we cannot use half into base into height because height is missing. So this was the confusion in the minds of many persons. Okay, they were confused about this, how to find area of these type of triangles. Okay, if base and height is given, it's okay, but if the triangle has three sides given to us, length of three sides, so how to find area of triangle? We cannot use this formula here, half into base into height. Okay, so what to do next? What should be done for this? This was a big question. So then came great mathematician called Herons. Okay, Herons was one of the greatest mathematicians who studied many concepts in mathematics, not only area of triangles. He was called hero of his time, okay, because of his research on mathematics. He was called hero of his time. So he worked on finding areas of triangles if three sides are given, and he derived and he came up with a formula, new formula, and that formula is named as Herons formula. So he said that this method cannot be used for finding area of triangle if height is missing, okay. So he came up with a new formula. Let's see that formula now. So he gave a new formula for finding area of triangle, that is under root s into s minus a, s minus b into s minus c. This formula is called Herons formula, okay. Now what is s, what is a, b and c in this? A, b and c are the length of the sides. A, B, C are the length of three sides of a triangle, and S is semi-perimeter, okay. S is what? Semi-perimeter. Perimeter means sum of all the sides, okay. When you add A plus B plus C, that is perimeter, but semi-perimeter is half of the perimeter. So S is semi-perimeter, A, B, C are the length of the sides. So this person, Herons, derived this formula. That is the reason this is called Herons formula, and this formula can be used to find area of triangles if length of three sides is given, okay. So let's proceed. So we'll find first perimeter of this complex. So we'll add up all this, 4 plus 5 plus 6, okay. This is the method of finding area of triangle if length of three sides is given, okay. You should, so this chapter name is Herons formula, okay. Even the chapter name is based on the mathematician name, that is Herons formula. So basically mostly we use this formula, Herons formula, in the whole chapter, along with some more formulae if required, okay. So here we'll first find perimeter. Perimeter, you know very well. We'll add up all the three sides of a triangle, we'll get the perimeter. So here the perimeter is 15 kilometer, okay. So we'll find semi perimeter, and A, B, C are the length of the sides. So let's proceed. So perimeter was 15, and 15 by 2 is nothing but 7.5. This is semi perimeter. Let's substitute this in the formula. Now what will be A, B and C? It can be anything, it's your choice. You can take A as this, and you can take B as this, and you can take C as 6 kilometer, or any way you can take. It's not compulsory you should take A as this only. You can take A as 6, B as 5 and C as 4 also, doesn't matter, okay. You'll get the same answer. So we found the semi perimeter. Let's substitute in the formula. Our formula is S into S minus A into S minus B into S minus C. Substituting in the formula, what is our S value? S value is 7.5, okay. You can see here S value is 7.5. Then S minus A, 7.5 minus 4, S minus B, then S minus C. We'll substitute all the values in the formula. Subtracting this, I'll get 3.5. Subtracting this, I get 2.5, and subtracting this, I get 1.5. And when you multiply all these three, you will get 98.4375, and the square root of this is approximately 9.921 square kilometers. So area of this complex, or you can say park is 9.921 square kilometer. So this was the opening question. Okay, so this is the most important method for finding areas of triangles in this chapter. Hope you all are clear with this. Thank you.